Hello Year 12 and welcome to the sixth video for our first topic, normal distribution, and we are looking at outliers today and particularly their effect on the rest of the dataset. What is an outlier? Well, it's a score that's significantly higher or lower than the rest of the data. What does significant mean? Well, it's kind of hard to say, or it has been until now. It's been an imprecise term, but I'm going to offer to you a calculation that you can use to discriminate here, to work out whether a score is an outlier or not. This is not the only way to do it, but this is the way that we do it in standard maths. So we are going to define an outlier as any score that is more than 1.5 times the interquartile range above the third quartile, or any score that is more than 1.5 times the interquartile range below the first quartile. This probably makes more sense when we use an example. It seems like a complex definition, but it's a fairly straightforward idea. Now, have a look here, and you can see we have a data set. It is unordered, right? And we know to find the quartiles and the interquartile range, if we do this manually, it needs to be in order. This takes quite a long time to put that in order. I don't particularly like doing that. It's very easy to make a mistake. What I'm going to do is show you how to do this on the calculator. So grab your calculator, my calculator. Remember to reset it first. Second function 9,3 equals AC. Get rid of any data that might be in there. Now we need to put it into stat mode. And because this is univariate data, it's not sort of paired up data, then I can just use option 1. Righto. So here's our univariate data. We're not going to put frequencies in. Right, we're just going to put in the scores one at a time. So we've got 11, followed by 8, followed by 12, and 12, and so on. And once you put all that data in, you should have 22 scores there. You might want to pause the video at this stage and follow along, put that data in. So here we are with our 22 scores. To find the outliers, I need to find the interquartile range Q1 and Q3. So let's say, now I think this is good working to show here. We're not going to write down all the numbers in order and show how we break them up into our quartiles. I'm going to just write this: Q1 equals, Q3 equals. Now my interquartile range, we need to know what that is. I'm also going to say 1.5 times the interquartile range. Righto. And then we want to have Q1 minus 1.5 times the interquartile range. And also we want to have Q3 plus 1.5 times the interquartile range. Okay, and that will tell me now the bounds for any scores that might be outliers. So here we go. Second function 1 to get to our stats. 2 for our data. Oh, no. All clear. Second function 1 to get to our stats. 5 for minimum and maximum. Now you see Q1 there is option 3, is 11, and option 5 here is 16. So 11 and 16. Those are my first and third quartiles. So the interquartile range is the difference of those numbers, which is 5. 1.5 times the interquartile range is 7.5. Right? Let's just recap that. I found Q1 and Q3 using my calculator in the min-max area menu. I find the difference between these two numbers here, right? 16 minus 11 is 5, is the interquartile range. That's what IQR is. I multiply 5 by 1.5 to get 7.5, and I use this as a measure, right? I go below the lower quartile and above the upper quartile to work out what our outliers are. So Q1 minus 1.5 times the interquartile range is 11 minus 7.5 is 3.5. Q3 plus 1.5 times the interquartile range is 16 plus 7.5 is 23.5. So this tells me now anything below 3.5 is an outlier. Have we got any scores below 3.5? No, we don't. I think 7 might be the lowest score, but I can't say any 1s, 2s, or 3s. So we don't have any outliers at the bottom end. Also, any score above 23.5 is an outlier. Now, do we have anything that's 24 above? Oh, look, here is, we can just check them all. Here is 25. What else we got here? That's all. So I can say, therefore, 25 is an outlier. Okay, right, that's too far outside of the rest of my data. Okay, so that's how we calculate outliers. We will do some work in this exercise about the effect of outliers, right? How they can have, particularly in a small data set, a disproportionate impact on some measures of central tendency in particular, and spread. So it can mess with the mean. It makes the mean look higher than a typical score, perhaps if I've got a really big outlier, or perhaps lower than a typical score if I've got a really low outlier. Also, it makes a big mess of our range where we have an outlier, because by definition, right, these scores are out at the edges of our data where we calculate our range. And if that's not like the rest of the data, then that measure of range, of how spread out the data is, could be a bit misleading. To avoid these effects of outliers, we might just calculate an outlier, remove that from our data set, and redo the calculations. That's one option. We can use other measures, right, of central tendency and spread to reduce or limit the impact of outliers. We can use the median to find a middle score, right? That's a nice way to do things. And we can use things like the interquartile range or standard deviation to calculate our spread. And the impact of outliers on those measures is much less. Rightio, that's outliers. Hope you enjoyed the video. I will, of course, see you in class.